Hi, this is Mr. Max with my second test on trigonometry, and then I threw in some revision questions for AS level. Okay, so the first question says find the value of the term which is independent of x in the expansion of x plus 3 upon x all raised to the power 4. What is important perhaps is this one here. When it says the value of the term which is independent of x, that is a constant term, so that's x raised to the power of 0. It's quite an important step for us to know. Alright, then I suggest maybe if you were to use Pascal's triangle, and you should be familiar with Pascal's triangle at this level, because what I want you to see is if you were to use Pascal's triangle, this becomes a plus b raised to the power of 0. This becomes a plus b raised to the power of 1. This is a plus b raised to the power of 2, a plus b raised to the power of 3, and a plus b raised to the power of 4, which is what this one basically is. So from this, our a is the x value, our b is the 3 over x. Okay, and also something with maybe with noting is that if you were to use the formula, and we'll be using the formula a bit to the towards to the end, maybe on the second question, but the general form of t sub r plus 1 equals to n choose r, or nr, where you have a, then you have n minus r, nb to the r. You can use that, or you can use the long way of Pythagoras, or Pascal's triangle. So I'll be using Pascal's triangle. So the first coefficients are the ones that I want you to pay attention to. That coefficients of 1, 4, 6, 4, and 1. Right? So our a value we said is x, so that becomes 1, and then x raised to the power of 4, and then I don't have to put the next one. Our coefficient now is 4, then x is going to be raised to the power of 3, then our b value is 3 over x, and now it's raised to the power of 1, plus 6, and then it's x squared, and then it's 3 over x also squared. I hope that you follow, plus 4, and this is going to be x raised to the power of 1, and this is 3 over x cube, and the last one will be 1, and then obviously 3 over x raised to the power of 4. So please take note of the coefficients as indicated. All right, so if you don't use a general form for this one, you can definitely also get to solve the answer. Well, if you work this out, this is x raised to the power 4 plus, now remember that's x cubed and that is x over there, so 4 times 3, that will give me 12x squared for that one, plus this one here is 9, 3 squared is 9, and then you have x here. So basically this one would be, if you were to multiply it out, maybe I should just write it down. So it's 6x squared times 9 over x squared plus 4x times, well, 27 over x cubed. But I'm not going to go so far because I think I'm going to get directly to the answer. So if I was to work it out further, it will be here in this case 6 times 4, 6 times 9, rather 6 times 9 is 54, and the x squares will give me x raised to the power of 0, and so on. Right, according to that, it says find the term, the value of the term which is independent of x, and the value of that term, because independent of x means it's just a constant term, and a constant term is 54. All right, let's say we take the same expansion, and I just want to bring in the clean page over here. So I have got x in bracket plus 3 over x raised to the power 4. Remember what I was saying, the general term is t sub r plus 1 equals to n r as a column vector a, then you have n minus r b to the r. Our a value, you see, the thing is we don't know what the value of r would be. R is representing the term. If I was talking about the uh, third term, the third term, R will equal to 2, because the third term will be 2 plus 1. That is going to give you the third term. Okay, the third term. But of course, we don't know the r, the position of the term, because I didn't write it in this case. The longer form, you can easily see that, wait a minute, that is the third term. But let's suppose I didn't do that, and I'm just using the general formula. All right, and that now implies that I'm going to work in this particular order. So I'm going to say, okay, n, or I'll say 4, which is that 4 over there, choose R, which I don't have, and then I've got my A value, which is X. That will be 4 minus R, that 4 over there. My B value, according to the formula, is 3 over X, and that should be raised to the power of R, using that general formula. Good. Now, for choose R, then I have got x raised to the 4 minus r, and I'm going to separate this. This is nothing but 3 raised to the r, and the other one is 1 over x raised to the r. Okay, you need to follow the steps. So 4 choose r, that is x, that's 4 minus r. Then I will bring this other one. This other one is just going to be x raised to the power of negative 1 r and 3 raised to the r power. So if I clean this up, I'm going to have 4 choose r, then I have x 4 minus r, and then I'm going to have x raised to the minus r power and 3 raised to the r. Now this is important perhaps for me to explain a certain concept over here. And the concept is, this is a constant, this is a constant. I'm not interested in the constant because I don't have the value of r. What I am interested in, I'm interested in the terms containing x. So the x for x raised to the power of 4 minus r times x raised to the power of minus r, I should let it equal to x raised to the power of 0, because the question is saying find the value of the term which is independent of x. When something is independent of x, that means it's x raised to the power of 0. Okay, so when you multiply and the bases are the same, you are going to add the indices. All right, and since the bases are the same, I can just equate them in any way. That's 4 minus r equals to 0. Now I'm going to get my answer, because 4 minus 2r is equal to 0. 4 equals to 2r. That implies that r is equal to 2. Now that I know what that is, I can go ahead and I can calculate, right? It's totally up to you. So this is going to be 4 choose 2, because we know what the value of r is, and then I have got x, then I'm going to have 4 minus 2, and then I'm going to have 3 over x raised to the power of 2. Okay, 4 choose r is a calculated value. All right, if you don't know how to calculate it, it's 4 times 3 to 2 factorial. Of course, this is 12, and that is 2 times 1, and that answer is 6. Ordinarily, you can also calculate this using your calculator. That is 4 shift, and here on the division, you see choose r, and then you press 2, you get that same 6 as an answer that I got. So this is 6, and you're going to have x raised to the power of 2, all right, times 9 over x squared. So this gives me 54 x raised to the power of 0, and therefore our answer is just 54. Okay, so let me get to question 2. Question 2 says a geometric progression for which, so it's in GP, for which the common ratio is positive, has a second term. So the second term of the geometric progression is 18. The fourth term is 8. The second term is 18. The fourth term is 8. Now, the formula for geometric progression is ARN minus 1. Okay, so we know we don't have the first term, we surely don't have the common ratio, but we know that the second term, n will be 2, is equal to 18. So that is AR equals to 18. That could be my first equation. Something else, A, then we have r raised to the power of 4 minus 1. We know that's 8. So this is AR cubed is equal to 8. And this is my second equation. So we are going to solve these two equations simultaneously by dividing one into the other. So I can say equation B divided by equation A. So that means equation B divided by equation A. That gives me AR cubed over, that is going to be AR should equal to, I'll just put the equal to like so, that's 8 over 18. So what's important that you should see here is that the A's are cancelling, and eventually that leaves me with R squared and 8 over 18. So I have got 8 divided by 18, well, that is 4 over 9, and if that is 4 over 9, then the value of r will be the square root, and I have to take the positive square root of that, and it's 4 over square root of 9. The answer is 2/3. They say the common ratio is positive. Right, so we now know what the common ratio is, and since we know what the common ratio is, we can go to any one of our formula, and I will choose this formula here in order for me to find the value of A. Okay, so let's see if we can find the value of A. I'm just going to insert a page here and see if that page would be at the place that I need it to be. Of course, it's not exactly where I wanted it. So I'm just going to go to the question and see. All right. So anyway, I can squeeze my working in here. So that is going to be, can use this place here. So A times R, which is 2 over 3, is equal to 18. Of course, that means A will be 18 times 3 over 2. And that gives me that our A value is 3. 2 goes there, 9 times is 27. Therefore, A is 27 and R is 2/3 is our solution to the question. All right, so let's go to the second part of that question. They say you must find the sum to infinity. So what do I know? I know that A is 27, and I will know that R is 2 over 3. The sum to infinity formula is A, 1 over R, 1 minus R. So therefore, the sum to infinity will be 27 over 1 minus 2 over 3. So let's quickly take our calculator. We say 27 over 1 minus 2 over 3, and that should give you 81. Okay, so the sum to infinity is 81. The next question, obviously you have got a diagram, and in this diagram you are told that OPQ is a sector. OPQ is a sector of a circle with center O. Then the radius R as indicated. Angle QOP is equal to theta radians. The tangent to the circle that Q meets OP extended to R, obviously forming that 90-degree triangle. So we are supposed to show the area of the shaded region. Here's the thing. The area of the shaded part will be the area of triangle OQR, which is the bigger one, minus, so the area, so let me just say, minus the area of sector OPQ. So we take the area of the triangle, then we take the area of the sector, and we subtract them. Here's the thing. They want us to give our answer in terms of the way it has been written here, a half r squared in bracket 10 theta minus theta. So it is important that we calculate what is the distance of QR. What we have basically is a right angle triangle. So we have a right angle triangle like so, and the distance O, this is Q, and this is O to R. At 90 degrees is there. So I will fill in what I have. I know that this distance here is R. I know that the angle here at O is theta. I'm interested in finding this distance OR over here. Because if I find, or the distance of QR rather. So I'm looking for distance of QR in terms of this angle and this R over here. And for me to calculate the distance QR, I'll have to use the tangent. The tangent of theta is whatever is opposite theta, in this case is QR, divided by the adjacent, which is in this case R. That implies that QR is equal to R tan theta. So if QR gives me that value, then I can definitely calculate the area of the triangle. So let's calculate the area of the triangle, but we're going to say triangle OQR. And I'm going to use the formula half base times height to calculate the area of that triangle there. So the area of the triangle is a half. The base can be R, and the height can be represented by R tan theta. All right, I just want to get my drawing correctly. So QR, the distance that QR I'm referring to, this distance is this distance over here. Okay, so my triangle is like so. So half base times height. So let's calculate the area of the triangle. So of course, if you multiply out this area, you're going to have a half r squared tan theta. What is the formula to calculate the area of a sector? Well, you will find down in the paper, you will see I also included a list of formula notations. So I'll just quickly scroll down to it. The formula notation that comes in your exam when you want to find the area of a sector, and you quickly just want to make sure that you know your formula is a half r squared theta. Okay, so I'll go back. So the area of the sector is now what I need to bring in, because I say area of the sector. So area of the sector. So let's bring in area of the sector, area of the sector, area of sector OPQ will be a half r squared theta. Right, so the area of the triangle minus the area of the sector. So that will be a half r squared tan theta, area of the triangle, minus a half r squared theta. Once you subtract these two, you will be left with, if you take out common factor, that's a half r squared. You will be left with tan theta minus theta. This is what we were required to prove anyway from the given information. The second part of the question asks us to find the length of the perimeter of the shaded region. Now, let me bring my triangle here, and it will assist me immensely if I have to calculate the perimeter. Good. Just want to bring it there so you can see, not going back and forth. We know from our previous working that QR is calculated. Our QR is nothing but R tan theta. Okay, R tan theta. So that I'm just want to write that in. QR is R tan theta. And I want to know what PR would be, okay? The distance of PR. So if we were to take this triangle, also arc QP is calculated by this formula. Again, you can go to the formula sheet if you want to know the arc length of a sector. I'll just scroll down there, and you can find the area, the arc length of a sector. So the arc length of a sector is the angle times the radius. So here we go, r times theta. And it's very important that you always make sure that you use the correct formula. Right, so I have my arc length. So let me just go back. I remember I'm looking for the perimeter of the shaded part. So basically, I have to add all those distances there. So this QP is nothing but theta r. Now, how do we find PR? So this is quite important. In order for me to find PR, I don't want to use Pythagoras. I first have to find OR. So I have a right angle triangle, like so. This here is Q. This here is O. And this here is R. Another thing that I know is I know that this angle here is theta. QR has been calculated as R tan theta. OQ is R. So I'll use the same ratio. I'm going to say, okay, I'm going to use the sine of theta, which is opposite in this case, a sine, or let's rather use the cosine. I'm going to use the cosine of theta is r divided by the hypotenuse which is the OR that we are looking for. That implies that OR will equal to r divided by cos theta. So if we have this distance r over cos theta, and I'm looking for P to R, then PR is going to be this r cos theta minus r. I hope you can see that, minus this OP. That's going to give me that distance. So now it's just a matter of adding them and replacing them. So this over here is r cos theta minus r. That's what the distance is there. So the perimeter can be calculated theta times r plus r tan theta plus r over cos theta minus r. Now, let me see, what do they tell me? They tell me theta is 0.8 and r is 15. So I have 0.8 times 15 plus 15 times the tangent of 0.8 plus 15 over the cos of 0.8 minus 15. Alright, make sure your calculator is in radian mode because you are working with radians. Right, so that's 0.8 times 15, 0.8 times 15, close the bracket, plus 15 tan of 0.8, close the bracket, plus you have got 15 over the cosine of 0.8, close, and obviously we are supposed to minus 15, minus 15. So we're going to get a number there, which is 33.9744. So it's 33.9744. And that would be centimeters. And to three significant figures, it will be 34.0 centimeters. Good. Next question. Show that the equation 3 tan theta minus 2 cos theta can be expressed as 2 sin square theta plus 3 sine theta minus 2 is equal to 0. One of the things you should know is that tan theta can be written as sine theta over cos theta. So I will say 3, where I have tan theta, I'm going to replace that tan theta by sine theta over cos theta, and let that equal to 2 cos theta. Then this is 3 sine theta over cos theta equals to 2 cos theta. Then this is 3 sine theta equals to 2 cos theta times cos theta. That is, if I multiply both sides by the cosine theta times cos theta. In this case here, it will cancel. This leaves me with 3 sine theta equals to 2 cos square theta. Right? So also, I expect you to know that sine square of an angle plus cos square of an angle is equal to 1. So what I'm interested in is this cos square theta over here. So I'm going to make cos square theta the subject of the formula. That means cos square theta will be 1 minus sine square theta. So I'm going to replace that cos square theta with minus sine square theta. So this is 3 sine theta equals to 2 in brackets 1 minus sine square theta. Alright, that is 3 sine theta equals 2. That is, if you are now going to multiply that 2, you distribute it over, and you're going to end up with 2 minus 2 sine square theta. And it's very important that you understand why I decide to change it to sine square theta, because my equation I'm supposed to prove is written in sine theta. Good. So from here on, you just bring over the other term. So it's 2 sine square theta. If I bring it to the left, plus 3 sine theta minus 2 equal to 0. And we have just proven that. Good. The next one, they will want us to solve the equation. So when we solve the equation, we just have to go back and rewrite our equation the way it was now calculated. Is 2 sine square theta. And let's just go back and see what's the rest of it. Plus 3 sine theta minus 2 plus 3 sine theta minus 2. This is a quadratic equation, all right? So you might not be able to see that this sine square theta, if it's in your way, you can say let sine theta be represented by u. That would be 2u squared plus 3u minus 2 equals to 0. This quadratic you can definitely solve. Two numbers multiply give you a negative 4, and if you add them, these numbers, they should give you positive 3. So it has to be 4 and 1, with the negative being on the negative 1. So that's 2u squared plus, this is now going to be split. This one here would be 4u minus the 4 coming from here, minus 1u, the negative 1 coming from here, minus 2. Now I have got 4 terms, and I can factorize by grouping then the like terms together. You should have exactly the same bracket, so minus 1 is a common factor over there, so it's 2u minus 1 in one bracket, u plus 2 in the other bracket, and we can go ahead and solve for u. Then this is 2u minus 1 is equal to 0, or u plus 2 is equal to 0. U will be a 1/2 if you solve it, or u is equal to negative 2. But remember, from what I said before, sine theta should equal to u. So I'm going to go back and replace that u with my sine theta. So this is sine theta equals to 1/2, or sine theta equals to negative 2. This one we have to reject because you can't have a sine of an angle to be bigger than 1, and 2 is a number bigger than 1. So I'm just going to work with sine theta equals to 1/2. Now they want me to find the solution between 0 and 360 degrees. So again, I hope you are familiar with the cast diagram, or you can use the unit circle. Basically, this angle we are going to look for, this I'm going to call it angle beta, all right, in the first quadrant, and in the second quadrant, theta or sine is positive, right? Sine is positive, all is positive here. So when we are now calculating the angle, so my key angle would be the inverse sine of 1/2. So what will be my acute basic angle? All right, since the story is supposed to take place in degrees, I'm going to change my calculator to degrees mode. The inverse sine of 1/2, of course, that is 30 degrees, and you should know that from your specimen angles. 30 degrees, that implies that in the first quadrant x would be 30 degrees, and in the second quadrant, so that will be that angle there. But in the second quadrant, if we have to look in the second quadrant, you will realize that you are dealing with an obtuse angle over here. So to find that angle, you will have to say 180 degrees minus our acute basic angle of 30 degrees. So in the second quadrant, our angle that we are looking for must be 180 degrees minus 30 degrees, which is 150 degrees, and these two are within our domain, and they are the solutions to that equation. Question 5, you are told to sketch the end label. Very important, because in this question you're getting marks for labeling. Sketch and label on the same diagram the graphs of y equals to 2 sine x and the graph of y equals to 2 cos x, or cos 2x, for the intervals 0, 0 to pi radians. That is the x and that is the y. So half of that would be pi over 2, half of that would be pi over 4, pi over 4, 2 pi over 4, this one here will be 3 pi over 4. All right, that's 45 degrees, 90 degrees. Remember that you have got 105 degrees and you've got 180 degrees. Okay, so always break it into sort of small parts so that it's much easier when you are trying 135 degrees. Okay, 135 degrees. So in degrees, for example, that's what I'm trying to get. This is 90 degrees. This is 180 degrees. This is 135, and this is 45 degrees. Of course, we are given our domain in radians, so we are not going to deal with angles in degrees here, right? But I have chosen those to be my key angles for now. Okay, so what I did is I have drawn a table below to help you out with the two functions. So I decided function f should be 2 sin x, and obviously those are the intervals as indicated on my diagram up top there. So I'm just going to see if I punch that in, what do I get? So use your calculator, it will help you sketching. So I'm going to use 2, and the calculator should be in radian mode. So let's just go ahead and change that. So it's now in radian mode. So I have 2 sine the angle of 0. You should know that this answer will also be 0. So that will give you 0 over there. If I bring that back, and if I go back in here and I replace that 0 with pi upon with pi over 4, or 1/4 pi, then I will get an answer which is square root of 2, which is about 1.4. So I'll write 1.4 more or less here. If I go back and I put 90 degrees or pi, half pi radians in there, and this is going to allow me to get 2. So the output is 2. And of course, if we go back and we put 3 pi over 4, what do we get? We get the same thing. We get a square root of 2. So square root of 2, we already determined it's 1.4. So the graph is coming back more or less. And if we go back and we simply go put in pi or 180 degrees, then we see the graph is oscillating backwards to 0. Okay, so if that is my table, I can actually sketch. But here's the thing, you see that the highest value, the highest output value will be 2. So it will be imperative if we can label that 2 maybe over there. And what I like to do, and I will advise you to do the same, is obviously maybe you can draw yourselves like a dotted line over there just to have that. Because that graph is going to be in that sort of region over there. The labeling is not too very important. Okay, when it's 0, well, it starts off at 0, like all sine functions, basic ones. When it's pi over 4, well, it's about 1.4. So 1.4, if 1 was here, 1.4 perhaps would be somewhere over here, all right? And I can maybe also get more or less the same for the other one, all right? A half pi is half pi is 2. Okay, so that goes and clocks over there, and when it's pi over here, it is 0 when you look at my table. Of course, this is more or less giving you an indication on how the function is. I'm just going to go ahead and do that just to bring it out nicely. I know it's a little bit out there. I'm just going to remove, remember we are sketching just those points over there so that it doesn't look too confusing, but this is not supposed to be something that is about difficult when you are if you were to draw this type of graph. So maybe I should start over with it. I know how the function should be because it will be going in 2 pi radians. I will have 1, and well, that is kind of interesting, but let's try it. And at first, if you don't succeed, hits there, it hits 1, it comes back. But of course, remember, it's definitely going to pass something like that. Right, I believe it's looking a little bit better um, than certainly those horrible ones. Okay, so that is my sine graph. So I will just say, okay, this is f. This one here is f. All right, and then the next one that we were supposed to find is cos 2x. Y equals cos 2x. Again, I have some values, my key values, and I will just use the same key values that I have here. That's why I made a table under, and I'm going to change my graph. So it's cos 2 open bracket 0 close brackets twice, and you get 1 as an output here. And if you go back and you put pi over 4, that is if you put pi over 4, then you're going to get an output of 0. And if you put half pi radians, that means I'm going to put 2 over here, where I'm going to get -1. Okay, and if I put 3 pi over 4, then that would be a 4 now, and that will be a 3. Okay, I get 0. Okay, and of course if I put in pi, right, let's see, if we do that, we put the value of pi over here, so pi, and I get 1. Right, so these are obviously showing you that the graph is oscillating between 1 and -1. So perhaps we can have our 1 over here, and we can have our -1 over here. That's what we mean by the labeling. Okay, right, so I'll also do the same. I'll bring in dotted lines. The one will be obviously over there, and one will be obviously over here. Okay, more or less you get the idea. Right, so for me to plot the graph is going to go obviously in that direction. When it's 0, it's 1, so the graph will definitely start over here. So it's going to start over here. When it's pi over 4 radians, I have 0, so it's going to definitely cut here. When it's pi over 2, it is nothing but -1, so -1 being somewhere here. When it's 3 pi over 4, I have 0 again, so it comes back up, and then this is where it's going to cross. And when it's pi radians, you will see that it is 1, so when it's pi here, 1 is somewhere up there. Alright, so from here on, it's just a matter of joining the graph as it goes. Can draw it lightly. Alright, it goes back up and back up again. Okay, and this green one can be my G. Right, that is a pretty good job on the sketching, and this is what you should do here. Labeling is very important, and you can see you have got half a cycle for pi. If it was 2 pi, it would half cycle for the sine curve, but if it was 2 pi, it will complete 1 cycle in 2 pi radians. Then the last question is asking, hence state the number of solutions of the equation 2 sine x equals cos 2x in the interval 0 to pi radians. Well, it simply means where the graph are intersecting, they will be equal. For this particular interval, okay, for this interval, you will have one intersection over here and one intersection over there. So 2 points of intersection, therefore 2 solutions. All right, 2 points of intersection in the given interval or domain. All right, therefore the number of solutions, it will have 2 solutions. All right, okay, I hope that you have picked up on a few items. Remember, if you want me to make my test available to you, just do drop me your email address, and I will send a clean copy of the test so that you can also practice. I did also a similar test on the first part, and I hope you also went through the video of those ones. Thank you for watching, and good luck with your studies.